Solving absolute value inequality, there are two cases. In the previous video, I explained the first case with a couple of examples. In this video, I will do case 2. Case 2 is a greater than the x minus m in absolute value, and then we have a greater than. The greater than is facing the absolute value. The mouth is facing the absolute value, and this is true for using the greater than or equal to. And then we have to break this down into two inequalities, x minus m greater than d, or x minus m is less than negative d. The or plays a very important role in here. Okay, so let me explain case 2 using a couple of examples. So first one, let's say we have absolute value x minus 5 greater than 2. So first we have to break this down into two inequalities, x minus 5 greater than 2, and then write the word or, x minus 5 is less than negative 2. Okay, the second inequality, reverse the sign and then put a negative in front of the right hand side. So add 5 on both sides, x is greater than 2 plus 5, and then or x is less than negative 2 plus 5, that is equals to 3. So this is your answer. And then this, we call this a solution set. How do you graph this? We have a 3, we have a 7. Now look. So we draw a line, and then this is a 3, this is a 7, small number on the left, big number on the right, less than 3. So we draw an open circle. There is no equal, then we don't use a solid circle. Less than, every number on the left hand side is less than 3. Again, small number on the left, big number on the right. 7, no equal, use an open circle, greater than 7. So this is from negative infinity to 3, and then 7 to positive infinity. When you use infinity, you always use a parenthesis. What is an infinity? So if you 3, you go to the left, you will see 2, 1, 0, negative 1, negative 2, negative 3, right? What is the biggest negative values on the left hand side? Do you have such value? What is the biggest negative number on the left hand side, the left end? Do you know what that is? No, you don't, right? There is no such number, so we cannot think of such number. Then we use a positive infinity. On the right end, the right hand side, what is the biggest value on the right hand side? 1 million, 10 million, 6 million, 1,000 million? We don't know, so that's why we use a positive infinity. All right, and then we have a number line. So this is number line. And then this is interval. Okay, I'm going to write another word right here. So this is interval. And then there is a conjunction between the interval, that is an or. This is very important. Why is the or so important? So how do you pick a number that satisfies the inequality? You have to pick a number that is either in the first interval or the second interval. So let's say you pick x equals to 0. That's fine. That's in the first interval. Can you pick a number that exists in both intervals simultaneously? That is impossible. You can do a x equals to negative 6, negative 10, or you can have x equals to 8, 100, 102, so on and so forth. Every time you pick a number, the number is either in the first interval or in the second interval. So that's why the or is so important. Okay, let's do another one. So let's do number 2. So number 2, let's do absolute value of 2x plus 8 greater than or equal to 20. So we break this down into two inequality, greater than or equal to 20, and then 2x minus 8 less than or equal to negative 20. Subtract 8 on both sides, 20 minus 8, divide both sides by 2. And then on the other side, we have 2x, add 8 on both sides, negative 20, plus 8. Negative 20, subtract 8 on both sides, negative 20 minus 8, negative 28, and then divide 2 on both sides, x is less than or equal to negative 14. So this is your solution set, and the conjunction is or, this conjunction is or. All right, and then we do our number line. we have small number on the left, big number on the right, greater than or equal to 6, less than or equal to negative 14. That's it. And then interval from negative 14 to negative infinity to negative 14, and then 6 to positive infinity. Okay, and then what kind of number satisfy the inequality? Now negative 14, negative 15, negative 16, so on and so forth. On the other side, you can have x equals to 6, 7, 8, 101, 110, so on and so forth. Every time you pick a number, the number is either on the left, first inequality, or the second inequality. So that's why the or is so important. Let's do two more. So switch color for the next one. So the next one, let's do absolute value, negative 2 plus some fraction, shall we? 5 over 6x greater than 7. Break this down, negative 2 plus 5 over 6x equals to 7. Oh, not equals to, why is that equals to 7? Greater than 7. And then negative 2 plus 5 over 6x less than negative 7. Solve that. Add 2 on both sides. So 5 over 6x. 7 plus 2 is 9. And then you multiply both sides by the reciprocal of the coefficient 6 over 5. 6 over 5, that is the only way to remove the 5 over 6. And then you have x greater than 54 over 5. And then this side you have a 5 over 6x less than negative 7 plus 2. And then you multiply both sides by 6 over 5. The reciprocal of the coefficient, 6 over 5. That is the only way to get rid of the 5 over 6. So we have x less than, oh, the 5 got cancelled, then you have a negative 6. What's the conjunction between them? The conjunction is or. So this is, what is this called? This is called solution set. And then the number line, we have small number on the left, big number on the right. So this is a greater than, and then this is a less than. No solid circle because there is no equal. Then from negative infinity to negative 6, 54 over 5 to positive infinity. 54 over 5 is about 10.8 to positive infinity. So let's pick a few numbers that satisfy the inequality. So let's say is negative 6 okay? Nope, negative 6 is equals to 6, so that's not going to work. Negative 7, negative 8, negative 8.01, negative 10, negative 999. The other interval, it can be 54 over 5. No. There is no equal. 11, 110, 15.8, 109.6, 200, so on and so forth. So every time you pick a number, the number must be either in the first interval or in the second interval. So that's why you need the conjunction or. Okay, last one. Almost done. So the last one, I would like to do some fraction as well. 2 over 3 x minus 5 greater than 30. So first we have 2 over 3x minus 5 greater than 30. And then 2 over 3x minus 5 less than negative 30. We add 5 on both sides. So 2 over 3, 30 plus 5. And then you multiply both sides by 3 over 2. 3 over 2. And then you have x greater than, this one I will just multiply the top. So the top after you multiply, then that will be 75. I mean 105. 105. 105 over 2. And then the other side, 2 over 3x less than negative 30 plus 5, you have a negative 25. And then you multiply both sides by the reciprocal of the coefficient, 3 over 2. And then we have x less than negative, this one is 75 over 2. And then the conjunction is or, so this is your solution set. and then we do a number line. So let's draw a number line. We have a small number on the left, big number on the right, 105 divided by 2. This negative 75 divided by 2 is negative 37.5. 105 divided by 2 is 52.5. Now, let's do a small modification. So the modification that I would like to do is, what if this is an equal? Greater than or equal to, so this will be equal, this will be equal, and then this will be equal. All right, then this will be equal, this will be equal, this will be equal. That doesn't change the or, but that changes the circle. So once you have an equal, then this must be a solid circle, and then this must be a solid circle. So greater than that, we shoot an arrow to the right. Less than that, we shoot an arrow to the left because we have small number on the left, big number on the right, and then the interval is from negative infinity to negative 75 over 2, and then or 105 over 2 to positive infinity. Did I make a mistake? The answer is yes, I make a mistake. Why? Because I use a solid circle. So since you use a solid circle, then this is supposed to be a square bracket, and this is supposed to be a square bracket. Because using square bracket means it is okay to let x equals to 105 divided by 2. It is okay to let x equals to 75 over 2. Other than that, you can have numbers like anything greater than 52.5, like 1,000, 2,000, including 53, 54. If you want to play with the intervals on the left, it can be negative 37.5, negative 1,000, negative 106, negative 205.55, those types of numbers, right? So how about this? Is x equals to 0, 1, negative 1, are these solutions? The answer is they are not solutions. Why? Because they are not in the interval, right? So that's why they are not solutions. Okay, so that is the end of this video. If you think my instruction is helpful, let me know in the comment below. Smash the like, share the video for me, subscribe to my channel if you haven't done so. Appreciate your help and support. See you all in the next video. Signing off for now.